So last year when I taught this course, I was teaching out of a book, and the topics don't exactly line up with what I have here in Newton, so we're recording this one as a little add-on to all my YouTube videos. In this section, we're going to kind of catch up on a few things that are covered in Chapter 8 in our book, and that's going to include adding things like this, adding things that don't have common denominators. So let's remind ourselves of a few things about working with fractions. If you want to add fractions, they'd have to have a common denominator. So that means two things you have to do before we really start adding them. One, you have to figure out what the common denominator is. And two, you have to convert to the common denominator. So those are two steps that we're going to practice a little bit before we start adding things that aren't like fractions. And we're going to start that with finding a common denominator. So find a common denominator. So for example, you could have a problem that asks you to find a common denominator between 3 over 10u to the 6 v to the third and 5 over 24 v to the second. Okay, so there's really going to be two parts of this. The first part is trying to find what would be the common denominator as far as the coefficients are concerned, and the second part is that for the variables. So I'm looking for the LCD, and to work on that with the number part, I'll show you two different ways. There's really more ways than this, but I'm going to try and keep it simple for you. If all you have to do is find a LCD for a couple of smaller numbers like this, kind of an easy way to do this would be to list some of the multiples of each of these numbers. So like 10, 20, 30. I mean, it's pretty easy to list multiples of 10. We can kind of see where that's going. So let's take a look at multiples of 24. 1 times 24 is 24, times 2 is 48, times 3 is 72. And then really you're just adding 24 to get from one to the next. So 24 and 72 would be 96. And then what? 120. And I think it should be pretty clear that if we let this pattern for the tens, multiples of tens, continue for a while, that eventually you would get to 120. And that's the first place where they overlap. So, okay, bless you. That's your LCD, at least for the number part of this. So let's put that down. LCD is going to be a 120. Now for the variables, well, we need to have every term represented. There's a u and there's a v. As far as the exponent is concerned, you want to list the highest power that you see. So the highest power of u that I see is 6. What's the highest power that I see amongst the v's? 3, and that's it. It's tempting. A lot of people want to add these and go, oh, okay, it's v to the 5th. You just list the highest power of each, and that's it. So here's your LCD. If you're fortunate enough to have a graphing calculator, they can make this part of things a little bit easier. So if you want to try and play along in this game, pull out your graphing calculator, hit the second button, and then down here, hit 0. So if you hit second and then 0, what that's going to give you is the catalog menu. It's going to give you a bunch of different commands. Now the command that we're going to want is not quite least common denominator. The calculator won't do that, but it will do the least common multiple, which for us in this case is going to work out to be the same thing. Now I can skip down, it's going to be a long ways to get to the L's. So rather than do that, right above the parenthesis you see the letter L. So if I press the right parenthesis, it'll skip me down to the beginning of the L's, and I can get to lowest common multiple. Let's type in our two variable or two numbers. 10, and then comma is right above the 7. 10 comma 24. Boom, 120. Yay! Better living through technology. Lisa, does that make your day? You got your $100 worth out of your calculator? Cool. All right. All right. So there you go. Nice little calculator trick for you there. But as far as this one is concerned, all we're trying to find is the LCD. So that's it. We're done. We're done with that one. I'm going to play that game again for a couple more, and they're going to get a little bit more challenging. Let's see. This next one's going to be similar to the last one, just to give you a little bit more practice with it. So 3 over 16, c to the 4th, d to the 3rd, and 7 over 10, c to the 8th, d to the 2nd. So let's again see if we can't find the LCD. Yeah, the fast way to do it is with this, of course. Bang, bang. And I'll type in a 16 there. But let's keep you in suspense for just a second more. If you're stuck doing this longhand, you can do this. 16, 32, 48, and keep going until you get to something that's clearly a multiple of 10. Oh, okay. 80. So 80 is your LCD, or at least part of your LCD. That's where these things overlap. This should give me the same thing. It does. 80. How about the variables, though? What power? Courtney, how many C's should I have? 8. How many D's should I have? 3. Good. Keep in mind, it's the highest power of each. Excuse me. All right, are we looking okay on those first two here? All right. Keep in mind that later on we'll be adding and subtracting these things, so you'll have to convert these denominators to an equivalent fraction with this denominator, and then we'll add or subtract. Like I said, these are going to get more challenging. So let's find the LCD. For these next two. So it's going to be 9 over 2y squared plus 11y minus 6, and 8y plus 4 over 2y squared plus 9y minus 5. Okay. Wow. That looks like a real mess. The thing you have to do, though, before you start panicking and going, oh my god, I'll never get this one, is factor the denominators. We need to see what they look like when they're factored. Now, I know from grading your tests that you're not fond of factoring these things. I think I know from just teaching you guys that you're not fond of these things. But you're going to run into them a lot. So let's practice how you factor these things and see what we can come up with. So this has got a 2 out in front of the y squared term. What's that tell us we have to do in terms of trying to factor this thing? Yeah, multiply a and c. Thank you. So it's going to be 2 times negative 6 is negative 12. I want to find two numbers that multiply to negative 12. And what else? Add to 11. Good. So two numbers that multiply to negative 12 and add to 11. Can anyone think of two such numbers? 12 and negative 1. Good. So those are the numbers that we're going to use. And we're going to split this up into two parts. So let me rewrite that as, bless you, 2y squared plus 12y minus y minus 6. Now it's got 4 terms. What's your automatic response when you're trying to factor something in with 4 terms? What do you try first? Grouping. Wow. Good job. You guys are making me look good. Thank you. Appreciate that. Did you know we're being recorded? Did I tell you that? Okay. All right. That's good. Appreciate you making me look good. Emma? I hope so. Yeah. We'll find out. I'm not stopping it now. If it's there, it's there. If it's not, it's not. Okay. So let's work on these pairwise. So out of the first pair, what could I factor out? 2y, which leaves behind y plus 6. What comes out of the second pair? Negative 1. So negative 1, y plus 6. So overall, y plus 6 times 2y minus 1. Got that one factored. Yay. Now I can do this one for you. I can let you do it. It's up to you. What do you want? You want to practice this one or? Okay. All right. So here's my little gimmick. I don't have a pause button on this. It just has to deal with the way this got configured. So I've got kind of a workaround for that pause. And it is my manual pause. So there you go. So when you're at home, you can just fast forward until you see that little slip of paper disappear. That's my manual pause. All right. I can get us some Jeopardy music. All right, hang on a second here. Jeopardy, think music. I hope I don't have to listen to a commercial to get 15 seconds of... Oh, this is 15 minutes. Wow. Oh, you know what, though? It's playing through my headphones, I think. So. Oh, this is cool. All right. You know, I'd unplug this, but if we're actually getting it to record, I don't want to mess things up. So, all right, you have to live without the Jeopardy music this time. All right, go ahead and see if you can't factor that. Let me walk around, help out. Same thing on this one. Okay, manual on pause. Like the last one, because there's a number out in front here, let's multiply the 2 times negative 5. 2 times negative 5 is negative 10. want to find two numbers that multiply to negative 10 and add to 9. 10 and negative 1. All right, good. So 10y minus 1y. These two stay the same. 2y squared plus that minus 5. And then as before, factor by grouping. Oh, you know what? Let's see. Oh, I better shut off the better shut off the Jeopardy music, otherwise we'll be competing. There we go. All right. That would be really annoying. Let's continue though. Let me slide back over to here. Factor out the 2y, leaves behind y plus 5. Factor out the negative 1. Again, it leaves behind y plus 5. So overall, we have y plus 5 times 2y minus 1. Yay. Or you can write it the other way. It doesn't matter. Let's take stock of where we're at. We've got 9 over y plus 6 times 2y minus 1 and 8y plus 4. Again, over a factored version of this would be y plus 5 times 2y minus 1. Now for this part, we don't really care what the numerators are. It's all just about the denominators. So let's look at the denominators and see if we can't figure out what the LCD is. So what terms should be part of the LCD? All right, 2y minus 1. So let's put that up there. 2y minus 1. Let's see, I guess I'll use this one. 2y minus 1. Now, do I need to have that 2y minus 1 squared because I got one here, or is it just to the first power? First power. It's always to the highest power, and well, the highest power is a 1. What else do I need there? Thank you. Y plus 5. So y plus 5. And one last term. Good. Y plus 6. So you have to have all the different factors multiplied to the highest power of each. Okay, not so bad. Not so bad. Keep this result around. We're going to come back to it later. We'll use that as part of a slightly bigger problem. But for now, let's practice the next step of this, which is convert to something and make something else an equivalent fraction. So the instructions that you'll see in Newton would be something like this. Bless you. Rewrite as an equivalent fraction. Equivalent fraction. Now, Newton will probably say rational expression, whatever, same thing. With a denominator equal to 3x minus 8 times x minus 5 times x minus 3. So that's the denominator that you want. Here's the fraction that you're given, though. 4 over 3x squared minus 23x plus 40. Okay. Well, essentially, I want to write that as something over this. The 3x minus 8, x minus 5, x minus 3. The key in this one is to factor this thing, is to figure out how that factors. Now, we've practiced that just a minute ago a couple times, so I'm going to help you out here. You'd want two numbers that multiply to what? Multiply to 120 and add to negative 23. Those two numbers eventually you'd find would be 15 and 8. But I'm not going to go through all the nitty-gritty of the factorization. It boils down to this. So 3x minus 8, x minus 5, x minus 3. Now that everything's factored, hopefully this doesn't look as daunting as it just did. What's missing here that I have over here? Yeah, x minus 3. So let's introduce that. I'll multiply by x minus 3 over x minus 3. Notice you have to do it in the numerator and denominator. Effectively, that's multiplying by 1. Multiplying by 1 doesn't change the value, but it will change how it looks in this case. Now, if I distribute this term in the numerator, then on top, what would I end up with? 4x minus 12. And that's probably all you're going to have to input into Newton, is this part right here. It's just the numerator. Because what they're looking for is, you know, what would make this an equivalent fraction, and you just have to figure out the numerator. This is now equivalent to this, but it has a different denominator. Let's try another one kind of like that, and we'll build on that one a little bit. We're okay with this one? I can't hear you. Oh, hey, good deal. Thank you. All right. So, let's see. 7 over x squared minus 7x plus 10, and 4x over x squared minus 8x plus 12. Okay. What do you think we should do first? If your goal here is just to find the lowest common denominator, how can we start? Factor it. Perfect. Thank you. So let's factor it. Bianca, how's the first one factor, please? Well, it has to be an x and an x. And this is the nice case of factorization, so that's good. Let me just switch over here. Bless you. Whoops. Wow. Rotate. Hope you're not getting dizzy there. Okay. There we go. All right, so the signs need to be both negative, right? 2 negatives here would make a positive, and then what and what? Thank you. -2 and -5. Good. Joe, how about the next one? How's that one going to factor? Good. Both negative. 2 numbers that multiply to 12 and add to 8. Good. 6 and 2. Yay. So now that we got them factored, that's cool. What's the LCD here? Try and write it down and then compare your answer with a neighbor. See what you think the LCD is. There you go. Manual pause. All right. Everyone got it right? Okay. Michelle, what'd you get for the LCD, please? Perfect. Basically, the product of all these factors, and we don't need this to the second power. It's just enough to list it once. So, cool. Let's take this problem a step further. What if I needed to convert this to have the LCD? So if I had 7 over x minus 2 times x minus 5 And I wanted to write it as something like this: x minus 2, x minus 5, x minus 6. What am I missing here? X minus 6. So just multiply by that missing factor. X minus 6 times x minus 6 would leave me with 7x minus 42 in the numerator. Likewise with the other one. With the other one, 4x over x minus 6 times x minus 2. What's missing this time? Good, x minus 5. So x minus 5, x minus 5. When I distribute that, 4x squared minus 20x. Thank you. Now, if you wanted to or needed to, you could add or subtract them because they have common denominators, whereas before we couldn't. But I think that's pretty good for this problem here. I think we got our money's worth out of that one. Okay, let's go back and look at one of the problems that we were working on earlier. Nine over 2y squared plus 11y minus 6 plus 8y over 2y squared plus 9y minus 5. Now we did this one earlier. We know how these things factor. In the denominator, that factors is 2y minus 1 times y plus 6. And this one factored as 2y minus 1 times y plus 5. What's the LCD for this one? Two y minus 1, y plus 6, and y plus 5. Thanks, Dallas. So let's save ourselves a little bit of writing and just kind of use what we already have here. Taking a look at the first term, what's this one missing that I have as part of my LCD? Good, the y plus 5. Y plus 5 over y plus 5. And over here, I'm missing y plus 6. So I'll multiply both of those two in. Now please, don't cancel. I mean, you could, but then you'd be back to where you started from, without common denominators. So don't cancel. Instead, let's multiply. So I'll do it in 2 steps. Let's distribute here. I'll get 9y plus 45. And over here, if I distribute the 8y, I get 8y squared plus 48y. Now in the denominator, I've got this times this times this. I got all 3 of them. But I'm going to be a little bit lazy here. I'm going to write LCD. LCD. Just for a little bit. Just because I don't feel like writing out the whole denominator. Right? I mean, I'm not done with the problem. It's not my final answer, but it's just kind of a little shortcut that I allow myself. Now that I have common denominators, I can add the numerators, right? So that would be 9y plus 5 plus 8y squared plus 48y over the LCD. I'm hoping that you don't leave it like that. For your final answer, I'd want a couple things. First of all, I want the LCD actually written out.
I think it's 9y plus 45.
It's 45. You know what? My bad. Oh, 45. There we go. Thank you. And then, let's see, I need one more term here. Y plus 5. But there's like terms in the denominator, or in the numerator here that I can combine. What can I combine? Good. The 9y and the 48. So 8y squared plus 57y plus 45. Yay. I wouldn't give you one this long and expect you to do more work beyond this, but you know, if there is some extra fancy cancellation here and factoring, you should do it. I don't think they're going to give you anything quite that nasty. At least I haven't seen it. So this is a good place to stop with that one. Are you okay with what we did on this example? That one all right? Okay. Let's do one more like that. Maybe a little bit more challenging because of some of the work we have to do, but it's going to essentially follow the same spirit. Seven over 2w squared minus 19w plus 9 minus 4w plus 3 over 2w squared plus w minus 1. How should we start? Factor. Excellent. Let's factor both of these. And let me help you out a little bit. This first one's going to factor as 2w minus 1 times w minus 9. Now when you're at home working on Newton, you'd start out by multiplying the 2 times 9 is 18. Find two numbers that multiply to 18 and add to negative 19. And that would be negative 1 and negative 18. And then factor by grouping, you'll eventually get down to here. Likewise over here, this one, you can actually kind of work your way through it by guess and check pretty good. The first terms has to be a 2w and a w, right? Because those two multiply together and give me that. The last terms multiply to negative 1. It's not too much that multiplies together to give you negative 1. It's either plus 1 and minus 1 or minus 1 and plus 1. So really you've only got two things to try. And that's it. And it works out, shockingly, gee, these match, right? 2w minus 1 and 2w minus 1. Meaning that's a plus 1 there. So why did we do that? We did that so we could figure out the LCD. Steve, what would the LCD be on this one, please? Good. And that's a plus 1 here. So let's look at our terms here and kind of figure out what we're missing. So, Brandon, what am I missing from the first one here that I have in the denominator, or that I have as part of my LCD? What am I missing? What's not here that is here? Plus 1. Yeah, w plus 1. Thank you. W plus 1, w plus 1. Cool. Brian, how about this one over here? What's missing from this denominator that's part of our LCD? Good. W minus 9. W minus 9. So let's come down to here. I'm going to distribute that 7 and get 7w plus 7. What's in the denominator? Anyone? Ah, well done. The LCD. Yeah, let's save ourselves some writing, right? Minus. Again, something over the LCD. But this time, what do we got to do to get that numerator? Right. FOIL. So that's going to be 4w squared minus 36w plus 3w minus 27. So all I did was I FOILed those two terms together. to get that numerator. I want to clean this up before I start trying to bring those together. So 7w plus 7 over the LCD minus. There's like terms here. What am I going to get when I combine those like terms? Yep. So 4w squared minus 33w minus 27 over the LCD. These both have the LCD. I've simplified them as much as I can. See if you can catch the mistake here, though. The way I'm writing this down, there's a subtle mistake that I'm making. I've got the LCD, so I'll put both of these over that LCD, but there's a subtle mistake. Yeah, you got to switch the signs because you're subtracting all of this. So that negative has to distribute itself to all three of these terms. So that would make the first one is negative, but the second one is positive, and so is the third one. Wow, that was weird. Okay, I've not seen it do that before. But did you see what happened here? Because you had to distribute that negative, it changed all of those signs. Here. Well, I guess I ended the same thing here. Last but not least, I've got like terms that I can combine. There's like terms here. And there's like terms here. Overall, we'll end up with negative 4w squared plus 40w plus 34. So you're just combining the like terms here, and these two combine to give me that. You still have it over the LCD, but at the last step in your problem, I'd really appreciate it if you would write what the LCD is. When I have to go searching for what the LCD is, I get unhappy. So please, keep me happy while I grade your exams. It's a good thing for both of us. All right? Okay. That's it. So to kind of recap, we first factored it so we could figure out what the LCD was. Once we figured out what the LCD was, we converted each of these so that they had the LCD. And then we were able to combine them. We should do a little bit of cleanup work here first. Then we combine them, combine the like terms, and finish off. Nice. All right. Hasta la vista to section 8.9D.